Because the Center for Breakthrough Medicines recognized the unmet need in the cell and gene therapy industry locally and nationally, we partnered with MLP Construction, both of us subsidiaries of MLP Ventures, headed by Brian O'Neill, who acquired the site around 2018 with plans for a life sciences services hub, out of which CBM grew.
The mission has been clear from our initial kickoff meeting to be a part of an overall mission to saving lives. And so since day one, we have been united together to put forth what will be the largest CDMO facility in the world.
At the conclusion of our current planned construction with MLP, CBM will include a total of 86 suites, 10 plasmid suites, 20 viral vector production suites, 36 cell therapy processing suites, and 20 cGMP testing, process development, and cell banking suites.
When it comes to this type of facility, how you design the facility is critical to the success of it, both from the obvious material costs as well as the cost of the overall footprint and efficiency. Every line that is drawn on paper essentially magnifies that degree of efficiency and in turn determines the degree of our alignment with the manufacturing philosophy of utilization. The goal was really to effectively get out of the way of the existing infrastructure and adapting the existing infrastructure to what's best for Center for Breakthrough Medicines. The final design of the facility becomes so much more of a design tool because it facilitates the process of navigating both the people and the materials as it goes from step to step. The design of the facility becomes critical to helping shape the policy, procedure, and equipment use. Because in reality, any deficiencies will exponentially grow as it scales up. Wasted space and inefficient procedures will essentially cost patients for generations to come.
There's well-established industry standards for the environmental controls and clean room grades and classifications, including air change rates and temperature and humidity controls specific to the various levels and grades that we want to operate. JB&B, our design and engineering firm, was instrumental in helping us work through all of the different options, and we wound up with a good balance of operational efficiency, protection of our products, and segregation of processes and client campaigns.
What JB&B has done so well is really painstakingly going through this facility and knowing exactly what we had to work with, to then be able to work together to say, all right, this is what we have to get to here, let's work together.
A lot of things with GMP, which stands for Good Manufacturing Practice, is to make sure its cleanliness level is met. So we had to understand the ISO classification for each space and understand how many air changes were needed. An air change rate means just the amount of air we're turning over a space over time. And the way we do that with HVAC solutions is creating positive pressure spaces, air that we pump into a space, pushing all those contaminants and particles out to the negative spaces. The air handling systems that serve these GMP type labs are always being treated with chilled water and steam from the main campus. So these large air handling pieces of equipment are moving around voluminous amounts of air throughout the building all the time. And it's so critical that they're treated, filtered, and brought to the space at the right temperature tolerance and relative humidity tolerance. The other key piece with GMP type labs is the amount of process laboratory gases that we're distributing around the facility to enable the operations to work all the time. Liquid nitrogen, compressed air systems, vacuum systems. And the key with laboratory gases is understanding any kind of hazard conditions that we're creating. There could be a rupture of the tank one time or a leak in the tank. And we have to make sure the right systems are in place for monitoring that kind of leak and exhausting the space. Utility power could go down any day. And we keep in place what's called emergency power systems and UPS systems. And UPS systems are essentially the bridge between when we lose normal power to when the emergency generator kicks on. Because the emergency generator could take anywhere from a minute to 2 minutes to come online and actually distribute power back to the facility. In the event we lose power and the emergency generators weren't working, you would lose whatever research they're working on at the time. We'd lose some specimens, some product they were creating, which would be detrimental to the whole research that we're working on here.
Cell and gene therapy manufacturing is hard. It requires tremendous investment. We're talking about $1,000 to $2,000 per square foot, an incredible amount of time. It can take 18 months up to 5 years to zone and build and qualify a plant. Our partnership with JB&B and Meyer has been so helpful in allowing us to build a best-in-class facility with high throughput manufacturing suites and all the support services so that we can deliver a center of excellence for cell and gene therapy manufacturing.
the therapies and the cures that are coming out of facilities like these. And that's what excites me, and I feel that's a responsibility. And it's my little small part as an architect to be able to contribute to that.